Okay, here we go with Unit 11, Sequences and Series. So the first thing you're going to encounter in this unit is something called summation notation. Summation notation is using this notation called sigma, which means to sum up the formula that follows. And you can see that this is, on the side it looks like an M, but it's actually an elongated S for sum. So our first example is the summation j equals 4, summation up 7, 2j minus 4. What this means, I'm going to type over here hopefully, is that we're going to plug in the numbers 4 through 7 for j and then add them up. So we're going to do 2 times 4 minus 4 plus 2 times, 2 times 5 minus 4 plus 2 times 6 minus 4 plus 2 times 7 minus 4. And you can do this horizontally or vertically, just as long as you use this number down here to start, this number up here to stop, and you plug in each and every one. So I'm going to just complete the math. We have 8 minus 4 plus 10 minus 4 plus 12 minus 4 plus 14 minus 4. And that gives us 4 plus 6 plus 8 plus 10. I'm just going in the order of the problem. And then I get 10 plus 8 is 18 plus 8 is 28. So if I was to take all these individual terms, which I did here, and add them all up, the total would be 28. This particular example is known as an arithmetic sequence, and this would be a list of numbers like 4, 7, 10, and 13 that goes up or down by the same amount each time. And this amount is called a common difference. In this example, it was 3. For example, we have 4, then 7, then 10, then 13. If we add 3, we would get 16, and then 19, and then 22, and so on and so on. In our next example, we look at 1, and then negative 0.5, negative 2, negative 3.5. If you look at the difference between this number and this number, you notice you go down by 1.5, and then you go from here to here, you go down by 1.5 again, making the difference a negative, and each time it's going to constantly be 1.5. Now, if you don't notice this, and it's going up, down, up, down, up, down, up, down, this would not be considered an arithmetic sequence. The common difference has to be the same, either a positive number if it goes up, or a negative number if it goes down, and the same number each and every time. If you were asked to calculate the formula for arithmetic sequence or sum, this should be sum. That's a typo on my part. Or this should be sequence. Here is the formula for the arithmetic sequence. It is a sub n equals a sub 1 plus n minus 1 times d. Well, what on earth are all of these? A sub n is our formula. It's kind of like y equals if you were going to put this in a mx plus b form. A1 is your start number. So it's wherever we start. It's whatever number you're starting with. We call this the starting term. And this is obviously addition. N minus 1 is, n is our variable, and it's minus 1 because it's the term before that's going to help us generate the next value, times d, and d is your common difference. Okay, so in our problem, our original problem with the 4 and 7 and so on, our first term was 4, n is our variable, and d is our common difference. So if I plug it in here, here's the formula. It's kind of hard to see in the middle of everything. If I plug it in here, I'm just going to change the color so it stands out. You see that 4 is our first term. Add in, which is part of our routine, n minus 1 times our common difference, which is d. And you can simplify this to 3n plus 1 if you wanted to, or you can leave it in this format. Now, this formula up here that I pointed out, and I'm going to highlight again at this time, and I'm going to change the color of. So if you were to go quickly through the video again, you could find the color. This piece right here is a formula for the arithmetic sequence that you must memorize. It's not given anywhere on the Regents exam. It's something that you need to memorize. and it is asked from time to time. If you were asked to find the 36th term, if you now have a formula for any term, which is what AN, I kind of think of it as any term, you could find the 36th term by plugging in 36. And you do 4 plus 36 minus 1 times 3. And you could have plugged it into this formula up here. I just chose to put it into the original. And if you had it either way, you would get 109. Okay, I thought there'd be more of a space here. I thought I made it that way. Sorry. Arithmetic sequence or series is a sum of a sequence. So anytime you see this word series, it means that you are adding up the terms of a sequence. So you may see it written as, if we use our original example, 4 plus 10 plus 13 plus 16 and so on. And this would be that you are going through and adding up each and every term in the sequence. But if you wanted to find the first 36 terms in our sequence, you can use the formula on the formula sheet, which is given like this. S of n is equal to n times a1 plus an divided by 2. Now this is given on the formula sheet, and I'm going to flip to the next page and show you the formula sheet as soon as we finish this. So to find the sum, S stands for sum of the first 40 terms, you plug in 40 for n, get 40, and then this isn't supposed to be 100. This is supposed to be 109, the value, not the actual term number. And this is my mistake here. Hold on, we have mistake typo in the rest of the problem. This would be 113 divided by 2, which would give us, hold on, since I made a mistake. I'm going to divide by 2 first, so I have 20 times 113, which would then give me, let's see, sorry guys, 2260. So 2,260 if I was to add up all the first 36 terms of our sequence. Sorry about that. And then on to the next, just to show you the formula sheet, and then we will end this recording. Oh, here's the formula sheet, sorry. If you notice, we haven't covered a lot of this information yet. In fact, we haven't covered any of it. But so this is the first piece that we're looking at, and this is the sum of a finite arithmetic series. The word finite just means countable. It has a start and has an end, and n is your counting numbers. So we're not going to have going to infinity. I'm sure most of you are relieved. And this is geometric, and geometric will be in our next video. Okay, so this ends video number 1 on sequences and series, and there's 2 videos for this unit.